Okay, so 7b, it's telling us that energy is conserved during the interaction. We've got to write a word equation relating the initial energy of the two nuclei when they are far apart to their energy when they are closest together. Your equation should make clear the kinds of energy involved. Okay, so when they're far apart, what we've got is essentially if they're far apart, they're not feeling the electric field. So we would say is we've got some kinetic energy, or the initial kinetic energy, and that is going to equal, as they move close together, obviously they're going to start repelling, so that is going to gain in potential energy, electrical potential energy. I don't think you need the word electrical, just as long as you're saying that it's a potential. Good spelling there, Newey. And if you recall, it says in the last part of the question that because there is some initial momentum, when they both come closest together, one of them has to be moving, so there would be also some final kinetic energy left over. Now we've got to show that the total initial kinetic energy of the two nuclei is 4.18 times 10 to the minus 27 U squared joules, where U is in meters per second. So let's come along and have a go at that. So if we take our deuterium, the kinetic energy of our deuterium is going to be a half times, because it's got a 3 times by the mass of the nucleons multiplied by U squared, plus the kinetic energy of the deuterium, which is going to be 2m times U squared. If we just multiply that out, so we've got 3 halves mu squared plus mu squared, and that equals 5m U squared over 2. And if you look onto your data sheet, the mass of a proton, the mass of a neutron, they're roughly the same, which is 1.67 times 10 to the minus 27 kilograms. So if we substitute that in, we would get 5 times 1.67 times 10 to the minus 27 kilograms multiplied U squared all over 2. And if you put that into your calculator, that comes out as being 4.18 times 10 to the minus 27 U squared. Okay, and on to this final part of this question. It's a little bit deceptive because this equation here isn't on the formula sheet, and I know some of you during the actual assessment you went, oh, should the R be R squared? Well, no, because the potential energy E of the two charges Q1 and Q2 separated by a distance of R is given by this, so this is the potential energy. If this was an R squared, then this would be the force. So what we need to do now, so this formula is correct, and for the hydrogen 3 and the hydrogen 2 to fuse, their separation must be no more than 1.5 times 10 to the minus 15 meters. Therefore, we've got to calculate the minimum value of U for fusion to take place. So, earlier on we said that the initial kinetic energy would equal the potential energy minus the final kinetic energy. So, if we rearrange that, my potential energy is going to equal my kinetic energy initial minus my kinetic energy final, and the charge on both of these ones, because they're both hydrogen, they've only got one proton, so if we substitute that into my potential energy, so that's going to be Q1 times Q2, well, they both got the same charge, which is the elementary charge because they've got protons. So if we square that, We divide that by our 4 times pi times epsilon naught, which you can look up on your data sheets as being 8.85 times 10 to the minus 12, and then our minimum distance is going to be 1.5 times 10 to the minus 15. Let's make that a bit bigger. So there's our potential energy term, and we know that that is going to equal 4.18, because that's the mass, sorry, that's half the mass of the half the mass. This is going to be the initial kinetic energy term, which we got from our previous question, times by u squared, and we're going to substitute minus 4.18 times 10 to the minus 27, and from the previous question we know that's u over 5 squared. We're playing around with the numbers. That tells us that over on the left hand side we've got 1.53, that's this entire term after being put into the calculator, comes in as 1.53 times 10 to the 13 joules, and that's going to equal 4.01 times 10 to the minus 27 squared. And again, if we rearrange that, that will come out as being u is equal to 6.18 times 10 to the 6 meters per second.